All right, what we're going to do now is what we call numerical approaches to solving composition functions. Now, it's in a way, solving composition functions numerically is almost like a puzzle, okay? Like, if you've ever done like Sudoku or something like that, that's very similar to, although that's more complicated. These are easier than Sudoku, at least in my opinion. All right, so the idea with numerical examples is you're not told what the function is. All you're told is the input that you're putting in and the output of that function if you put that number in. So f of x is some function where if you were to plug a 2 in for x, the answer, the output would be 10. G of x is a completely different function where if you were to plug a 2 into g of x, the output would be -5. For example, f of x might be, now I'm not giving it to you, but let's just say for the sake of argument that f of x is x cubed plus 7x, so minus, I got here 14 plus 8 is 22, minus 12, okay? To where if you put a 2 in, 2 to the third power is 8, plus 7 times 2 is 14, that equals 22, minus 12 is equal to 10. So f of 2 is equal to 10. Now I'm not saying that this is what f of x is, I'm just saying that that is a possibility, okay? We are not told what the function is. All we're told is that if we plug a 2 into the function, the answer, the output, would be 10. If we were to plug a 2 into this function, the output would be -5. Then we're told that h of x, a third function, is a composition function of f of x and g of x. Okay? That h of x is f of x divided by g of x. Okay? And so now the question that's being asked is, well then what is h of 2? Well, the way we're going to solve this is since x is being replaced with a 2, we're now going to write f of x over g of x, but we're going to replace this x with a 2, and we're going to replace this x with a 2. And what we come up with is that this is going to be f of 2 divided by g of 2, which we were given. F of 2 is 10, g of 2 is -5, and 10 divided by -5 is -2. Therefore, h of 2 is, the answer is -2. This is a numerical example. Okay, let's try another example. All right, here's another one. This one's just a little more complicated. Why don't you see if you can figure out what h of 4 is given that information over there. Pause the video, give it a shot. All right, so h of 4 is equal to, now this is based on h of x, so what I'm going to do is I'm going to rewrite this whole thing, but everywhere we see an x, I'm going to put a 4. So x squared, which is now 4 squared, right, minus 5 times, instead of f of x, I'm going to put f of 4, plus 6 over g of, instead of g of x, I'm going to put g of 4, okay? Now I can replace I can replace the f of 4 with what f of 4 is equal to, which is 7, and I can replace the g of 4 with what g of 4 is equal to, which is -3. I'm also going to resolve this 4 squared, so 4 squared is 16 minus 5 times f of 4 is 7, so I'll put a 7 in here, plus 6 over g of 4 is -3. Okay? Now I can just do some arithmetic. 16 minus 5 times 7 is 35, plus 6 divided by -3, that's -2. So I'm actually going to get rid of this plus and put in -2 or -2. Okay, and so now the answer to h of 4 is 16 minus 35, which is, what is that, -19, minus 2, oh, I went too fast, this is -19, okay, minus 2 is -21. So h of 4 is -21, okay? This is a numerical example of solving a composition function, okay? Let's try another example. All right, really ramping up here. These are just so you know, these are kind of the easier questions. We are going to try a couple more difficult questions in a few minutes. All right, so we have some information here, h of x, f of 0, g of 0, and we want to know what h of 0 is. Why don't you go ahead and pause the video and try this. All right, so h of 0 comes from h of x, so we're going to rewrite this whole thing, but we're going to replace all the x's with zeros. So what we're going to have here is f of 0 squared, right, minus 11 times g of 0, right? And so f of 0 is 9, so that's 9 squared minus 11 times g of 0, which is 4. And so this is going to become 81, because 9 squared is 81, minus 11 times 44, or 11 times 4 is 44. And so h of 0, 81 minus 44, that is 37, right? And so h of 0 is equal to 37, okay? Let's try another example. All right, so here's another kind of numerical composition function. You're given a few pieces of information here. We're told that the function f, if you were to plug a 3 in, if the x value is 3, the output value is 7. If you were given 10 in the same function, the output value would be 3. Then, in the g of x function, if you were to plug in a 3, the output value would be 10. And if you were to plug in 7 into g of x, the output value would be negative 4. And so now you're being asked, what is f of g of 3? Now previously you were asked something like, what's f of g of x? And you would take an analytical function and put it in for all of the x values in the other function. Okay, here you're given numbers. And here's what you're going to do. When you're being asked what is f of g of 3, what you're basically doing here is you want to know what f of a number is. And that number, the number you want to know to plug into f, is whatever the output of g of 3 is. Well, what is the output of g of 3? G of 3 is equal to 10. And therefore, g of 3 is the same thing as 10. So what they're really asking here is, what is f of 10? And that's given to you. What is f of 10? Well, f of 10 is 3, and therefore f of g of 3 is equal to 3. Okay? Now we're being asked, what is g of f of 3? And so what that means is we want to put in these parentheses whatever f of 3 is. Well, what's f of 3? f of 3 is 7. Therefore, that is going to go inside the parentheses. And what we now want to know is, what is g of 7? Okay? And g of 7 is negative 4. Therefore, g of f of 3 is equal to negative 4. Okay? I'm going to give you another one that's a little harder than this, but uses the same basic idea. All right, so here's another example where we're going to try and identify two different composition functions. There is a lot of information over here. We may need all of it. We may only need a couple of these pieces of information. In numerical problems, oftentimes you are given more information than you actually need. And a lot of times that additional information is meant to confuse you to find out whether you really know which information you need and which information you don't need, which really isn't that big of a deal, because if you know how to do the process, the extra information becomes just irrelevant. You just go find the information you know you need. We want to identify h of g of 3. So we know that the input into h of x is the output of g of 3. All right, well, what's g of 3? G of 3 right here is 5, okay? So this g of 3 is just like there's a 5 sitting here. So this is the same thing as what is h of 5. Well, h of 5 is right down here. H of 5 is 1, and therefore that is our answer. We're done. Now this one's a little more complicated, obviously, because it has all three letters, right? It's f of g of h of 2, okay? Now, the way I do it is I go inside out. I start inside the egg, the thing that's nested all the way inside, and I just find out its value and work my way out. Okay, well, what is h of 2? h of 2 is 3. So this thing right here is essentially the same thing as a 3. So what I really have here is f of g of 3, right? I replaced the h of 2 with a 3. Now, what is g of 3? We already know what g of 3 is. We did it up here, right? g of 3 is 5. So this is the same thing as f of 5. Well, f of 5 is given to us. It's all the way over there. f of 5 is 11. And therefore, the answer to the second one is 11. Okay? All right, the last thing we're going to do with this numerical thing is I'm going to put up a large table of values with multiple functions, and we're going to do what I call mega table. Okay, here is a table. I think you should pause the video and you should create this. It's 5 rows and it is, let's see, 16 columns all the way across. Okay, and in just a minute, I'm gonna break the video and I'm going to fill in the table, but I want you to understand what's going on here. We have 4 functions: f of x, g of x, h of x, and k of x. X is all these values across the top. These are input values. And so the idea here is if I were to plug -2 into g of x, this would be the output value. So I take the function, I take the input value, cross them over, that's the output value. If I were to plug a 0 into k of x, this box would have the output value and all the way down. So we've got output values for 4 different functions. Okay, all of these outputs, so the 4 output values that'll be in these 4 boxes right here will be the outputs from plugging -3 into each one of them. And these numbers could be the same or they could be different, okay? So I'm going to go ahead and enter in all of the output values. All right, so I've gone ahead and filled in all the output values for these 4 functions. You may want to consider pausing the video and putting all of these into your table. And now what I'm going to do is I'm going to give some additional information right down here so that we can answer some questions. All right, now here is some additional information that you're going to want to write down. I have defined 5 additional functions: m of x, which is f of x plus g of x, they're up here; n of x, which is h of x to the power of k of x, h and k are both up here; p of x, which is equal to 3 times m of x, this m of x is this one right over here, okay, minus h of x times k of x; r of x, which is the quotient of h and g, h of x divided by g of x; and then u of x, which is a composition function here of r of f of x. So we're plugging f of x into r of x. Here's r of x. So we would be plugging f of x into the x's in h and in g, okay? And so now what we're going to do is I'm going to put some questions up on the board that we're going to try and solve using all this information from mega table, okay? All right, so the first thing I want to know is I want to know what is f of g of 5, okay? F of g of 5. So this is sort of an easy start here. Well, in order to identify f of g of 5, I need f of a number. I need to turn g of 5 into a number so that I can find f of that number. The input into f is the output of g of 5. So I'm going to go find g of 5. Here's g. Here's 5. G of 5 is -2. Therefore, I'm going to replace g of 5 with a -2. So really what I'm asking is, what is f of -2, which comes right out of the table. Here's -2. Here's f. F of -2 is 13. And so the answer to this question is 13, okay? All right, let's try another one. How about g? Let's reverse this. What is g of f of 5? Okay? After doing that one, do you want to try this one on your own? Pause the video and try that out on your own. All right, so I need the input into g. Well, the input into g is the output of f when you plug in 5. So 5 gets plugged into f. Here's 5. F is the top row, so f of 5 is 8. So what we're really asking for is, what is g of 8? 8 is right here. G is the second row, therefore g of 8 is -27. And therefore, g of f of 5 is -27. Okay? All right, let's try another one just like that. What is h of g of 5? Well, this is very similar to what we just did because we already did a g of 5 up here. Why don't you try that one out on your own? All right, so to get the input into H, we need the output of G from an input of 5. So G of 5, here's 5. G is the second row, that's -2. So we're looking for what is H of -2, right? Well, H of -2, here's -2, and H is the third row, so that's 46. And so H of G of 5 is 46, okay? Now we're going to try some more difficult problems here, where we're going to try and do triples, okay? So a function inside of a function inside of a function. So let's try, how about f of g of k of 9, okay? And so now what we have to do is we're going to have to do a couple different steps. We're going to work our way inside to outside. So the first thing we need is, what is k of 9? Okay, well, here's 9 over here. K is the bottom row, so k of 9 is 1, right? So we're going to replace k of 9 with a 1. So what we now have is f of g of 1. All right, well, now to plug into f, we need to know the output of g. What's g of 1? Well, here's 1. G is the second row, so G of 1 is 11. So what we really have here is, what is f of 11? And that's easy to find. Go to the 11. F is the first row, that's 0. And therefore, f of G of k of 9 is equal to 0. Okay? And now I'm going to give you one more of those. I'm going to see if you can figure it out on your own. We want to know, what is k of h of f of 3? Why don't you pause the video and see if you can figure this one out on your own. All right, so we got to work our way inside out. The first thing we need to know is, what is f of 3? Because whatever the output of f of 3 is, that's our input into h. F of 3, here's 3. F is the first row, that's -1. So we're going to replace f of 3 with a -1. So we have k of h of -1. All right, so now to know what we're plugging into k, we need the output of h of -1. Here's -1, h is the third row, that's a 10. Okay, so what we really have here is k of 10. And k of 10, here's the 10, k is the bottom row, that's -12. Therefore, the answer is -12. Okay? All right, now let's do some that involve these 5 crazy-looking composition functions here. Okay? And what is m of 4? Let's identify m of 4. Well, to identify m of 4, we need to use m of x. And so we've replaced the x with a 4, so all we have to do is write out what m of x is equal to, which is f of x plus g of x. But instead of putting x's, we're going to put the 4 in for the x's here. So we're going to have f of 4 plus g of 4. And we can get that information right from the table. F of 4, here's 4. F is the first row, 3. So we're going to replace the f of 4 with a 3, plus g of 4, well, that's 2. So we're going to put a 2 here, and 3 plus 2 is 5. And therefore, m of 4 is equal to 5. Right? Let's try n of 6. N of 6. Do you want to try that one on your own? You want to pause the video and see if you can figure this one out? So we're going to use n of x, but in place of the x, we're putting a 6. So that means we're going to put a 6 here and a 6 here. So we're going to do h of 6 to the power of k of 6. Well, what's h of 6? Well, we'll go to the input of 6. H is the third row, that's a 5. So we'll put a 5 to the power of k of 6. Well, what's k of 6? Here's 6. K is a 4. K of 6 is a 4. Therefore, this is 5 to the 4th power, and 5 to the 4th power is 625. You may need a calculator to do some of these, but 5 to the 4th power is 625. All right, let's see here. Let's do, let's do P of 7. P of 7. All right, well, P right here is kind of crazy. We have 3 times m of x, which is that m of x all the way over there, minus h of x times k of x. So we're going to replace the x with a 7. That means in each one of these places, we're going to replace the x with a 7. Okay? I'm going to pause now. Why don't you pause the video and see if you can try this one on your own. It's a little crazy, but I think you can do it. All right, so I'm going to rewrite this whole thing, but everywhere I see an x, I'm going to put in a 7. So 3 times m of 7. minus h of 7 times k of 7. And the h of 7 and k of 7, they come right out of the table. But before I do those, let's go ahead and work on m of 7. M comes from m of x, and that's f of x plus g of x. But wherever we see an x, we're going to put in a 7. So this is now actually going to be 3 times, and I got to put this in parentheses because this is a sum. Okay, so because we're multiplying by 3, we got to put it in parentheses because we're going to have to distribute. Or, well, we'll just add the two numbers together and then multiply by 3. So we'll have f plus g, so that'll be f of 7 plus g of 7, all right, minus h of 7 times k of 7. And all of these come right out of the table. So we need f, g, h, and k of 7. Well, here's the input of 7. F is 19, g is negative 17, h is an 8, and k is a negative 3. So we're just going to go, let's see, we're going to have 3 times. F is 19 plus negative 17. That means minus 17. So it's 19 minus 17 minus h is an 8 and k is a negative 3. So in parentheses, I'm going to put an 8 times a negative 3. Okay? And now that's going to be equal to 3. What's 19 minus 17? That's 2. 3 times 2, that's 6. Negative 3 times 8 is negative 24, and we're doing minus negative 24, so that's plus 24, and 6 plus 24 is 30. And therefore, P of 7 is equal to 30. And I know that that was a difficult problem to do. It was very bulky, a little confusing. In fact, I recommend you back up the video and do that again if you're not sure how I did it. If you do that same problem 3 or 4 times, I promise you, you'll get a lot better at this. All right, let's now identify r of 2. We're almost done. And r is a function of the quotient of h and g. Okay, so we're just going to plug in 2 for the x's. So we're going to have h of 2 divided by g of 2. Well, h of 2 is 17. G of 2 is negative 3. And so that's basically just negative 17 over 3. Okay, that's our answer, negative 17 over 3. Now, if this could be simplified, you would simplify it. Okay? All right, last one. U of negative 1. So what we're going to do is we are going to plug in negative 1 here for x, which means we're going to plug in negative 1 in here. So what we have is r of f of negative 1. All right? What is f of negative 1? Let's do that first. See, r is right here. We're going to have to break this out into h divided by g. Now, there's a couple ways you can do this. You could put the f of x or the f of negative 1 in here and in here, or you can just go get your number first. Well, what's f of negative 1? F of negative 1 is 9. And so what we really have here is r of 9. And now we're just going back to the previous problem, r of 9. We're just replacing these x's with a 9. So it's going to be h of 9 divided by g of 9. And h of 9 is 12. And g of 9 is negative 6. And 12 divided by negative 6 is negative 2. So the answer to u of negative 1 is negative 2. Okay? All right, so that is numerical composition functions. And I'm going to give you plenty of practice for this so that you can have lots of chances to try and improve your skill in this. And the last thing we're going to move to is graphical composition functions.